All right, so we're still working on derivatives, guys. So we're still finding the derivatives, which means what are we still able to find with a derivative? Slope of a tangent line, velocity of an object at a specific time, and instantaneous rate of change. What does that mean, by the way, rate of change? Where it's increasing, decreasing, or what else can I say? Not no change or constant, right? So those are the things. So the only difference is now is we're still taking derivative, but it's just the way our functions are presented to us. Okay. So it's like what I told you in the warm up. If I have two functions that are multiplying together, obviously multiplication is a what? It's a product. So I'm going to use my product rule. And then if I have two functions that are being divided, then I have the quotient rule. Okay. So like in our warm ups, we were able to simplify. We were saying, look, I can actually FOIL these, create one equation, and just use my power rule, right? In the quotient, in this quotient, I was again able to simplify. I can put everything over x, and then simplify, get one equation, and again use my power rule, right? So your power rule is kind of your go-to. But in some cases, not only are you not able to do that, it's just kind of more work for you to have to do that, okay, when you have rules just like this. So here is your product rule. Okay, here's your product rule. It says, first of all, if the two functions f and g, so I have two functions, I'm going to call them f, I'm going to call them g, are differentiable, meaning that the derivative does exist, then their product is also differentiable. So here's the important part. So if I have f times g, and again, what does this symbol mean right here? Prime, so which means I'm taking the derivative of it. If I'm taking the derivative of f times g, then here's my rule. Take the derivative of f times my original g plus my original f times the derivative of g. Okay? So copy that product rule. We'll talk about it one more time. Okay, so here's your rule. Here's your rule, guys. If you have two functions that are being multiplied, when you want to take their derivative, you simply take the derivative of the first times the second. Notice, did I take the derivative of the second at this point? No. So it's a derivative of the first times the original second plus the original first times the derivative of the second. Okay? So you're going to split this up into two functions if you see two functions. Yes, ma'am. What? This? No, it's the prime. It's the like the apostrophe. That just means the derivative. Okay? So here's what I have. Here's my first function. It says y equals parentheses 3x minus 2x squared parentheses 5 plus 4x. Okay? And they want me to find y prime, which means they want me to take the derivative, right? So do you guys see, first of all, that these are being multiplied, right? And do you see that technically I can think of them as two different functions, right? I'm going to call this one f, and I'm going to call this one g. Okay? I'm going to call that one f, I'm going to call that one g. And then, so my rule says that it's what? F prime of g plus f g prime. That's what my rule says. Okay? So just literally put them separately here. Okay? So the derivative of f. So basically, only looking at this, what's the derivative going to be? 3 minus 4x. And what did you use there? You use your power rule, so you can use your power rule. So I have 3 minus 4x times my original g, which is 5 plus 4x. And then it's going to be plus my original f. So 3x minus 2x squared times g prime, which is the derivative of just the back. What happens to this 5? Goes away, and then what's the derivative of 4x? 4. So here, basically there's a 4 there. I don't know if you can see it. Okay? So basically that's my rule being applied. Now, all I have to, so I did take the derivative. Now all I have to do is simplify. All I have to do is simplify. What are these things up front doing? They're FOILing, right? So they're being multiplied. So we can FOIL everything. So 3 times 5, of course, is 15. 3 times 4x, of course, is 12x. Negative 4x times 5 is negative 20x. Negative 4x times 4x, negative 16x squared. And then over here on the back part, what are they doing? They're just distributing. So it's 4 times this, 4 times that. So it's plus 12x minus 8x squared. And then now simply, guys, combine your like terms. Combine your like terms. And probably put them in order. So what's going to go first? Your x squared. So I have a negative 16x squared and a negative 8x squared. Negative 24x squared. And then I have a 12x, and a negative 20x. 4x. And then, of course, I have my plus 15. So there's my derivative. There's my derivative. Again, what does this equation represent? This is the slope of the tangent line at any point, right? So if they gave me an actual point, then I could simply do what? Plug it in to find the actual slope, the rise over run, okay? The rise over run. So there you go. That's your product rule. So if you have two functions, that look like they're being multiplied, you can essentially just split them up, okay? You can essentially just split them up. And think of one as f, one as g, and follow this rule, okay? For instance, here's our next one. Y equals the cubed root of x squared, parentheses, 2x minus x squared. Okay? Is there something wrong with it right now? The radical. So I want to change that. Okay? Before I even get started, I want to change that. So what is this really going to be? X to the 2/3. Everybody good with that? And then I still have my 2x minus x squared. Okay? And then, again, just establish which one's f and which one's g. Okay? So when I find the derivative, so take the derivative of f, so it's going to be what? 2/3 x minus 1/3, parentheses, just your original g, plus x to the 2/3 times very good. And then now distribute and simplify, right? So just simplify. Okay? So does everybody see that this is being distributed, right? Okay, and so 2/3 times 2 is what? 4/3 x, and then what do you do to the exponents? You add. So you have a negative 1/3 plus 1. So negative 1/3 plus 1 is positive 2/3. And then do the same thing. So distribute to the back. So it's going to be a minus 2/3 x. And then I have a negative 1/3 plus 2. What do I really think of 2 as? Not 6/3. Yes, 6/3. My bad. I was thinking 4/3. So negative 1/3 plus 6/3. 5/3. Plus, and then here, what's going to happen? 2x to the 2/3 minus 2x to the, so it's 2/3 plus 1, so it's actually 5/3. Okay? Can I combine things here? Yeah, I have like exponents, right? It's like if they were both squared, I would combine them. So do you see that I have an x to the 2/3 and an x to the 2/3? So I have a 4/3 plus 2. So this is where your fractions, guys, come in. So 4/3 plus 2 is really 6/3, so it's 10/3. So 10/3 x to the 2/3. And then I have the two 5/3, right? I have a negative 2/3 and a negative 6/3. So negative 2 plus negative 6, negative 8/3 x to the 5/3. Okay? So again, we need to get good at fractions. We need to be very good at fractions. Okay? And good. Last thing, put it back how. And I still keep seeing a lot of this mistake here. Am I going to send this to the bottom? Why not? It's not negative, so it's fine. So it's just going to be 10 thirds cubed root of x squared minus 8 thirds cubed root of x to the fifth. Kind of ran out of room there. So it can get tricky, guys. It can get tricky. You just have to know what you're doing. Just go piece by piece. Make sure you can add, subtract, and multiply fractions. Okay? So, product rule, product rule. See if you can do these. See if you can do these. Alright, so I'm not trying to trick you here. I threw in some sines and cosines, right? Do we know those derivatives? You should. You wrote them down at least, right? I told you to memorize them. First of all, is there any products going on here? Yeah. This is 2x times cosine of x. So technically I have two functions here. They're just not as complicated as the rest. So this is my f, this is my g. So when I do the derivative, what's the derivative of f? So it's going to be 2 and then times g, which is 2 cosine of x plus 2x, and then the derivative of cosine is what? Negative sine. So actually I can change this from a plus to a minus sine of x. And that's just this front part. That's just this front part. And what's the derivative of this back part? So derivative of sine is cosine, and remember the rule is if you have a constant, just leave it. So minus 2 cosine of x. Can I simplify this? So I have 2 cosine of x and I have a minus 2 cosine of x. So they are actually going to cancel out. So it's left. So y prime is equal to negative 2x sine of x. So a lot of students get tripped up right there because there are two functions there. There are two functions. Notice that they are separate, okay? Next one should be more your speed. Obviously, I have two functions here. I have 6x cubed minus x and 10 minus 20x. This is going to be my f. This is going to be my g. Does it actually matter which one I make my f and which one my g, do you think? No, because they're multiplying, right? Isn't it the same thing anyway? All right. What's my rule say to do? The derivative of f, right? So the derivative of f times g plus f g prime. Okay, just to help you out. What'd you say, Caesar? Okay, so he said it's 18x squared minus 1. Where do you get that from? It's the derivative of f, right? Okay, times the original g plus the original f times the derivative of g. Now what? Simplify. FOIL and combine like terms. Okay? So, I like to write everything out, which would give me what? 180x squared minus 360x cubed minus 10 plus 20x, and then on the back part this is just a what? Distribution. So minus 180x cubed. Oh, my bad. Just checking if you are paying attention. 120x cubed plus 20x. Can you combine? What? So, negative 360, negative 120, negative 480x cubed. So those are gone. What's next? The positive 180x squared. That's gone. So, did I do something wrong? Oh, this should be a positive, right? Yeah, because it's a negative 1 times a negative 20, so that's a positive 20. So then it's plus 40x minus 10. You could, right? So Jasmine's saying, look, you can at least you can factor everything out by what? By 10. It's really not necessary, right? It's not necessary, but you could if you wanted to. If you're really trying to go that extra mile. So then it would be what? 48x cubed minus 18x squared minus 4x plus 1. I would probably say not to because I have a feeling most people will mess up here and forget that plus 1. And so if you do that, then you were wrong. Okay? So you don't have to simplify because we're not even using it, right? All I told you was to find it. So it's not like we're going to apply it or anything like that. Okay, so any questions on the product rule? So this is a new rule for you to memorize. So now you have two rules. You have a power rule, and now you have a product rule. Okay? You have a power rule and you have a product rule. Notice, I used my power rule for my product rule, right? Because I had to take the derivative of those little parts. Okay? And that's what's going to end up happening, guys. You're going to keep using these rules inside of each other. Okay? There's one that's the worst. It's called a chain rule. It's literally a function within a function. So it's like a function inception. Okay? Any questions on the product? All right, well, this lesson had two titles. We learned about product. Now let's talk about my quotient rule. Okay? Let's talk about my quotient rule. It's the same kind of situation. I have two functions, but instead of them being multiplied, now they are being divided. Okay? So I just have another rule that I have to learn. More like memorize. Okay? So if I have two functions, f and g, and I want to take their derivatives, the rule is simple. F prime of g minus f g prime, all that over g squared. All right, so does this top part of my formula look kind of familiar? It's kind of like my what? It's kind of like my product, but what's the biggest difference? It's the minus sign, which is actually where most people will make their mistake here. So because things are being multiplied back here, right? These things are being multiplied. First of all, because of PEMDAS, I'm going to multiply these two things before I even add or subtract, right? So don't forget that. So you're going to have to multiply the front part and the back part first before you add or subtract. But where most people will make their mistake is here. Because it's subtracting, this is why I like to kind of put brackets there. You have to remember to distribute that minus sign. You have to remember to distribute that minus sign. Okay? And then notice on the bottom, that is just g squared. Okay? It's just g, whatever g is squared. There's no kind of derivative on the bottom really. It's just g squared. All right, so here we go. Here's our first example. I have y equals sine of x over x cubed. Y equals sine of x over x cubed. Does everybody see, first of all, it's in my form, right? It's in my quotient. So my f is sine and my g is x cubed. Got it? So then my rule says f prime g minus f g prime, all that over g squared. Okay, so then give it to me. So cosine of x times g, which is just x cubed, minus, and again I like to put brackets here, sine of x times 3x squared. All of that over x cubed squared. Okay? There's really not much I can do here except simplify and make it look pretty. Okay? So, do you see how this is written? It says cosine x, x cubed. You see how that can kind of look confusing because the x's are right next to each other? So one of the things we do is really just put the x cubed up front. Does it really matter? Not arithmetically, right? Not algebraically, but aesthetically, it's more pleasing to say x cubed cosine of x. Okay? X cubed cosine of x. And then here, it's the same situation, except what's going to happen, people? And so it's going to become a what? Negative 3x squared sine of x. And really, the only kind of simplification or algebra I can do is that bottom part. What's x cubed squared? So when you're multiplying, you add the exponents. But here, I have an exponent to another exponent. So the rule says to multiply them. So this is actually going to become x to the sixth. Okay? X to the sixth. Will they count points off? No, but if they can't read it correctly, so like if I didn't have that product symbol, you know, or sometimes it's better to put parentheses, like so it's just because remember this is a human being reading this, and human beings have their preferences and stuff like that. They try and make them all grade the same, but it's just gonna. These are all teachers. These are all AP Calculus teachers that do this from around the country. So, does anybody? Can I do anything else? Maybe this is kind of an algebra. Do they all have something in common that I can take away from all three of them? An x squared. Does everybody see that? They all have at least an x squared. So now this one has an x cubed. Can I take away three of them though? And the reason is no, because this one doesn't have three. So actually, this can become, this will just go away, right? This becomes just x, and then this becomes x to the fourth. So that's as simple as it's going to get. So x cosine of x minus 3 sine of x over x to the fourth. All right, next one. I have f of x equals x squared plus 2 over the fourth root of x. Any issues? So this is really x squared plus 2 over what? X to the 1/4. X to the 1/4. Again, this is my f. This is my g. Apply my rule. So the derivative is going to be what? What is it again? Again? Just 2x, right? Because that's the derivative of the top. Times what? X to the 1/4. Minus, again, I like to put brackets, x squared plus 2 times negative what? Negative 3/4. All of that over x to the 1/4 squared. All right, your algebra is getting tricky here. It's getting tricky. What's going to happen up front? These are multiplying, so what am I doing? Yeah. So you're adding the exponent. So 1 and 1/4 becomes what? So 2x to the 5/4. Now, again, be very careful with this back part, because I have actually two things going on here, right? This has to be distributed to both, and then I have to make it minus, okay? So let's do it one at a time. So 1/4 x to the negative 3/4 times x squared is going to be a what? X to the, think of this as 8/4, so 5/4, and then it's going to be a minus because of that. And then here, same thing. What's 1/4 x times 1/4 x to the negative 3/4 times 2? Positive or negative? Again, because of that minus sign. So minus 1/2 x to the negative 3/4. All of that over, what do I do here? To the half. So it's going to be x to the 1/2. Can I combine anything? The 5/4. Um, so 2 and negative 1/4. So 7/4 x to the, can I change it to a radical? 4th root of x to the 5th. And then now this is where it can get really weird. Because I'm going to have a fraction within a fraction. Because see how this is negative, right? But I'm not going to take it to the bottom of the whole thing. It's just the bottom of this. I'm going to treat this as its own little fraction. So it's going to look like this. 1 over 2 4th root of x cubed. And then all of that over the square root of x. Can get very, very tricky, guys. We have to get good at adding and subtracting and multiplying fractions. Okay? We have to get good at it. Quotient rule, quotient rule, quotient rule. So now I have 3 rules. Now I have 3 rules. They're all viable options, okay? Whoops. Why don't y'all try this first one? Just the first one. Okay, so this is obviously my f, this is my g. So w prime of z here is what? 3 times 2 minus z minus 3z plus 9 times negative 1. Very good. All of that over 2 minus z squared. Okay, so then of course I'm going to distribute that top part, so that would give me 6 minus 3z. And then over here there's also distribution, but then again don't forget about the minus. So this should have been a negative 3z, but then it's a positive 3z. And then this should have been a negative 9, but then it's going to turn into a plus 9. Now this is where I hope you did not waste your time. You don't actually have to FOIL that out. You could just leave it as 2 minus z squared. But if you did, it's okay. The reason you don't FOIL out because, well, let me show you why. So does anybody see what's going to happen here? They're going to cancel. I'll be left with what? 15 over 2 minus z squared. So if you FOILed this out, you got what? Z squared minus 4z plus 4. And then so 15 over that. So let me just write that. Z squared minus 4z plus 4, right? So do you see why it's not necessary? The reason I would actually want to FOIL this out is in hopes that something on the top would what? Cancel. So do you see how nothing cancels? So there's really no point. So you really didn't know that. So and remember, things are better canceled when they're in factored form anyway. So leaving it as 2 minus z, maybe there on the top there would have been another 2 minus z that I could have gotten and canceled, okay? But you really don't have to do, you don't really have to FOIL out the bottom if it's an equation like that. Okay, a couple more. We only have about 10 more minutes here. I have 4 square root of x over x squared minus 2. Can I rewrite this? 4x to the 1/2 over x squared minus 2. Okay? So again, this is my f, this is my g. So that gives me 2x to the negative 1/2 times x squared minus 2 minus 4x to the 1/2 times 2x, all of that over x squared minus 2 squared. So that's going to give me, if I distribute that front part, that gives me what? 2x try your fractions. Negative 1/2 plus. So I'm thinking of this as a what? Not a 2 over 2. 4 over 2. So negative 1/2 plus 4 over 2 is 3 over 2. Okay, and then this becomes minus 4x to the negative 1/2. And then this becomes 8x to the 3/2. And more specifically, it's a negative. All of that over x squared minus 2 squared. Can I combine anything? The 3/2. So a negative 2 and I'm sorry, negative 8 and a positive 2 give me. It's negative 6. Can I switch that to a radical? Square root of x cubed minus 4 over square root of x. All of that over x squared minus 2 squared. Okay, so this is your quotient rule. Now you have 3 rules, like I said. You have 3 rules. You have your power rule, your product rule, your quotient rule. It all depends how. How do you know which one to use? How the equation is set up. Okay, if the equation is set up in a quotient, you're going to use your quotient. If the equation is a product, you're going to use your product. If it's a very simple equation, you can use your power. But notice you're using your power rule throughout the whole thing. All right, that's the basic, okay? So, again, this is an AP class. You're trying to get ready for your AP test. They are not going to simply ask you questions like this and say find the derivative. They're going to ask you questions like, suppose the amount of air in a balloon at any time t is given by this function. Okay? Determine if the balloon is being filled with air or being drained of air at t equals 8. So, what are we talking about here? It's a rate of change. Very good. It's a rate of change. Because the balloon is either changing in what, by the way? What is that called? What is that called? Volume. We're talking about volume, right? We're talking about volume. So the balloon is either getting bigger or it's getting smaller. So that's a rate of change. Very good. I'm glad y'all noticed that. So this is just a rate of change. So then they're telling us to take the derivative. They're telling us to take the derivative. And all they want to know, now notice how the question is. It says determine if the balloon is being filled with air or being drained. They don't want to know how much air. So all they really want to know is if it's what? Positive or negative. Does that make sense? So does everybody see? Tell me what we're going to do. We're going to take the derivative. Well, I don't need to find 0 because they gave me t equals to 8, right? So I'm going to take the derivative. Plug in 8. And then determine positive or negative. That's it. Okay? Determine positive or negative. So, can I take this derivative? That's the question. Can I take this derivative? So, the way it's written, is there an issue? So, it's going to be 6t to the 1/3 over 4t plus 1. Okay? So, I'm going to give you a hint, guys. I'm going to give you a hint on these kind of problems. Don't get caught up in the simplification, because what do we really want? We really want to plug in 8. So I'm not ever going to present my answer as here is my derivative, like the equation part, you know what I mean? Like it's not going to have a bunch of t's in it because they want a number. They want a number. So what I'm saying is don't get caught up in the simplification because, like on the last examples, I mean, if we're here, right? So does everybody agree that technically this right here was the derivative was taken, right? The rest two steps were simplification. Do you see my point? My point is don't get caught up in this because at this point, couldn't I just plug it in anyway? And I get the same answer, right? So I don't want you to get caught up in simplification on word problems because they're never going to see your simplified anyway. It's all about the answer, right? It's more about that process. So really just take a very basic derivative, just apply your rule, right? Don't get caught up in the simplification. We'll plug in because the calculator is going to do most of the work for us anyway, and then we'll go from there. So let's start with the derivative first. So v prime of t. So what do you got? 2t to the negative 2/3 times, because I got to use my quotient rule, right? 4t plus 1 minus times 4. All of that over 4t plus 1 squared. So there is my derivative. Does everybody agree with that? That is my derivative. It's just not simplified. Could I simplify? Sure, if I wanted to waste time. Okay? Remember, this is a timed test. You did your derivative. Now, let the calculator do the dirty work. So this is where it's interesting. Does everybody know how to put a fraction into a calculator? Right? Alpha y equals. Do it that way. Make sure it's a fraction. Do not try and sit there with a bunch of parentheses and all that and division. So make it look exactly like this. It's going to look exactly like this. 2, 8 to the negative 2/3. 4, 8 plus 1 minus 6, 8 to the 1/3 times 4. All of that over 4, 8 plus 1 squared. Okay? Actually, the easiest thing to do is go to your y equals and put the equation in and then do your table set. You know how to do, you know what I'm talking about? You know how when you can put in any x for the table, right? So that's the easiest thing is instead of, because notice over here, if I misplace a parentheses, I'm screwed. So really, I would just put my equation in y equals, go to your table set, and change your independent to ask, so you can give it the value that you need. In our case, 8. So go to y equals. Can you help me? What was my equation? Six x times 4. No, because if in this case, what I'm doing is I'm putting the equation, and then I'm going to go change my table, or actually I can go to my table, and look for when 8 is equal, when x is 8, right? Did y'all get that number? Okay. So when x is 8, when x is 8, we got negative 0.0299. Is that right? 289. So actually the point was what? The point is that this number is what? Negative. So then you have to interpret that. So what does that mean? At t equals 8, the balloon, notice how they worded it. Is being what? Is being drained of air. This is what they want to see. If you don't write this, you did not answer the question. Okay? Because the question wasn't give me a bunch of numbers. The question was determine, was it being filled or was it being drained? So the numbers just get interpreted by you. In our case, because it was negative, it was being drained. So again, the biggest thing here, being filled or being drained, this was a rate of change. All right? This was a rate of change. All right.